In this section, we will be giving names to our values. In Reason, we can give names to the values using let bindings. For better understanding, you can think of them as of variable assignments you might be familiar with from JavaScript, for example. Let bindings are effective from the moment on you write them down until the end of your program. Let's start this section with an example. Now this is our first let binding. And syntax for let bindings is that we first write the let keyword, followed by the name of our identifier, and equal sign, which is followed by an expression. The expression calculates the value to which you want to assign the name. We don't need to declare the type of this identifier, since the type will be inferred by the compiler. As you can see, in our case, we got an integer. A very important feature of functional programming languages is that the value of an identifier never changes. This means it's immutable. The exception to this is when the identifier explicitly contains a mutable value. But we will talk about this in the future sections. Once we have defined a name and bound it to a value, we can use it later in our code. Now, what if we now bind our num identifier to a different value? Let's try that. Now we got 32. And although let bindings are immutable, we can still give a new definition of an identifier with the same name we already used before. What is happening here is that we've defined a new identifier called num, which just happens to have the same name as the old one, which means that the old definition will be shadowed, and it will be hidden for the moment. So, the old definition is still there and can still be accessed in other ways. So it is the last binding which is active, and we can verify that by typing the name of our identifier. Now we got 32 back, since the original num identifier was shadowed by the newer one. Now we will be talking about block scope in Reason. Our previous definition was a global one, since it was available throughout our program. However, we can also define locally scoped definitions using block scope. And typical use case for block scope are if expressions. So let's take a look at the example. Now, our workshop identifier is locally scoped. And the scope is the region of the program where a particular let definition is effective, and is defined through curly braces, as you can see in this example. Now, what will happen if we try to access our identifier in the global scope? Let's try that. Now, if we try to access our local definition in the global scope, we will get an error, because the workshop local definition is scoped, and thus is not available in the global scope. Local definitions work almost the same as the global ones, except the scope will be delimited by the syntax. Local definitions hide more global definitions. Let's take a look. In the global scope, the name identifier equals Yoda, while in the local scope, it equals Han. You may write down several definitions, local and global ones, using the same name. If this is the case, then the most local definition, the most inner one, always has priority over more global, more outer definitions. And since bindings are scoped through curly braces, we can also create an anonymous scope around them. Let's take a look. Now we use anonymous scope and we define there name identifier. And then we also try to access name identifier inside global scope. So let's try to run it. So we create anonymous scope here, and then we write name identifier inside of it. And then we also try to access the name identifier in the global scope. And we got an error since the name identifier is visible only in the local scope. And using these anonymous local scopes enable you to prevent misuse of the locally defined bindings since they are not accessible globally.